Hello and welcome to today's video where we're going to talk about some basic examples with numbers, so numerical examples of similarity. So a touch on what we talked about in the last video, just an introduction to similarity. Two polygons are similar if they're the exact same shape but slightly different size, not slightly, just a different size, but they have to be proportional. So the size differences have to be proportional and the angles have to be congruent. And the symbol for similarity is just the tilde. So if I wanted to say triangle ABC is similar to triangle DEF. I actually wrote that right there. Just type that in. So that's what that means. That's the similarity symbol. So let's look at an example here. ABC is similar to DEF. So I can just take triangle ABC and maybe multiply it by 2, but multiply it by some constant to get triangle DEF. And you can create these ratios here to help you figure out side lengths. And that's what we're going to be mainly working with in this video. So definitely make sure you have this committed to memory and what it means by proportional. So I can take the side length of one, the corresponding side, divide by the corresponding side on the other triangle, and that has to equal the same thing with the other two sides. So first example, find x. So we see that the two triangles are similar because they have the same angle measurements. Well, how do I know that they have the same angle measurements? Well, the symbols help me out. But then I also, what's key here is that I'm only given 2 of the angles, but it says that all angles have to be congruent. So you kind of have to take it one step further. So if 2 of the angles of a triangle are the same, the third one has to be the same because you would just do 180 minus the 2 other angles to get the third. So I can add this in here. I'll do 3 dashes. So that is another way to say that these are all the same. They're all congruent. So angles are good. Angles are congruent, so that's good. And now we're going to assume that triangles are similar. So now how do I find x? So I'm saying, remember it says corresponding sides are proportional. So this side, the one I'm given, corresponds to this one. And then this side corresponds to x. And it says corresponding sides are equal. So if I do 20 corresponding ratios, so 20 divided by 12 needs to equal 15 divided by x. Did I say they're congruent here? This should be AC equals, and AB over DE equals BC over EF, and AC over DF equals BC over EF. That should be equals, not congruent. Okay. So now back here. So now if we're just solving for x, we do 15 times 12. And what is 15 times 12? That's going to be, well, 15 times 10 is 150 plus 30 is 180. So 180 equals 20x. Then just divide both sides by 20. X equals 9. So that means this side must be 9. So we solve for x. So that's the way you set up these ratios, you set them equal to each other, and you're good to go. Okay, so next example. Find x. Okay, so this one's a little bit tougher. So we're assuming that the outside triangle is congruent to the inside triangle. So this larger triangle here, you see this, the outside one is congruent to this inside one where we have this one. Okay, so now side lengths have to be proportional. So the outer side length here I have is 12, right? So 12, what side is that corresponding with on the other triangle? Well, that must be this here. That has to be that 9 because that's the bottom side of the triangle. This one is a 12, that's the whole triangle, and the smaller triangle has a side of 9 there. That has to equal, well, now we need to be careful. So obviously we're going to be working with this side here. And what is the measurement of the larger triangle? Know that we need the larger triangle on top because we used the larger triangle's measurement last time for the top ratio. So the top of the ratio is going to be 6 plus x because that's the length of the larger triangle's side. So it's 6 plus x divided by, and what's the length of the smaller triangle side there? Just the 6. So 6, and then we solve for x here. So let's see what we get. We cross multiply, so 12 times 6 gives us 72 equals 9 times 6 plus x. Then I'll distribute that 9. I'll get 72 equals 9 times 6 is 54 plus 9x. Subtract 54 from both sides. we'll get 18 equals 9x. What does x equal? It equals 2. So x equals 2. So there again, we're using the same ratios, setting them equal to each other, and that helps us solve for x. So that's a little bit tougher of an example. It's hard to kind of imagine what the big triangle is and the small triangle, but not too bad. Okay, so we have one more, it looks like. So a triangle has side lengths of 6, 8, and 11 inches. A second triangle has side lengths of 8, 16, and 22 inches. Are the triangles similar? So what we have to do is we need to set up all the ratios and see if they're all equal to each other. So we have 6 divided by 18, and we're comparing that to 8 divided by 16, and we're comparing that to 11 divided by 22. And be careful here, because the way I actually wrote it is not the best way to do it. So even though we're given the order of 18, 16, and 22, the first step needs to be to sort them by smallest to largest. So if I have the smallest to largest on the top, I'm going from 6 to 8 to 11. Well, the corresponding sides must be the same on the other triangle. So while they listed it to me in 18, 16, and 22, we need to switch it up to where it's 16 here. So 16, 18, and 22, because that's the only chance that they could be similar, is if they have the same order of smallest to largest, or else there's just no way. So, and we're not given any other information about the triangle. We're not given that, it didn't say that the triangle was ordered a certain way, so we have the liberty to kind of move that around to give it the best chance per se of being similar. So that's what I did there. So now I need to compare the fractions. Are they all the same? The first thing I would notice is that this is an easy fraction. 11 over 22 is 1/2. So now the only thing I need to prove is are the other ratios 1/2. 8 divided by 18 is not 1/2. 6 divided by 16 is not 1/2. So no, they are not similar because they do not share the same proportionality across all sides. So that's the way you do something like that. So that's a little bit different, but it's still using that same rule right here, which should be equal signs instead of congruent signs. My bad. But hopefully that makes sense why they're equal signs. Okay, so that was some numerical practice with similarity. Hopefully that's kind of making a little bit more sense now. So similarity, same shape, just a different size. Thanks for watching. Let me know if you have any questions.